Hi everyone, this lesson is on still evaluating limits in indeterminate form, but we're going to be using a change of variable to make an equivalent but easier limit. And that's going to be a really important technique that you need to know for university. So change a variable to make an equivalent limit that's easier to solve. And then we're also going to do a few examples at the end, just kind of consolidating our skills with evaluating limits. So evaluate the following limits by creating a simpler equivalent limit using a change of variable formula. So if you look at this right now, you have the limit as x approaches 0 of x plus 8 all to the 1/3 minus 2 over x. So the stressful part of this question is this x plus 8 to the 1/3. Okay, that looks yucky, and that's what we're going to use to help us make our change of variable. Notice that just, if this was an easy one, we would have been able to substitute x, but we can't because that would leave the denominator 0, so it is an indeterminate form. So we use u, textbooks, and tend to always use u for their change of variable. So we let u equal the part that makes us uncomfortable, or the tricky part of the question. So we're going to let u be x plus 8 to the power of 1/3. And you may remember from grade 11 that the power of 1/3, let's see if I can show this up here. If you have, like, say x to the 1/3, or let's even make it a number, that will help us remember a bit more. We had 8 to the 1/3, for instance. That means the third root of 8, okay? Which means what number multiplies by itself 3 times to give you 8? It's 2. Remember back, but this isn't 8 to the 1/3. It's x plus 8 all to the 1/3. So we let u be that yucky part, okay? So now that means that I can replace this with u. Okay, but I have to make my whole limit in terms of u, so I have to be able to replace this with something in terms of u, and also this, x, with something in terms of u. So if I want to get x by itself here, so that I would be able to replace this x, I could put both sides here to the power of 3. So if I put this side to the power of 3, then I need to put this side to the power of 3. Because by the exponent rule for power of a power, you keep the base, x plus 8, but you multiply the exponents. And 1/3 times 3 is just 1. So we have that u cubed is equal to x plus 8 to the power of 1, but we don't need to show that. So that's going to help us when we need to replace this x. I'll show you that later. The other thing we have to do is replace this limit. So as x approaches 0, well, up here we said we're going to let u be x plus 8 to the 1/3. So as x would be approaching 0, u would be approaching 0, because as x approaches 0, u is going to approach 0 plus 8 to the 1/3. Or 0 plus 8 is just 8 to the 1/3, which we said was the third root of 8. So u is going to approach 2, the third root of 8. And if you're not sure, again, how do you do that on a calculator? You could do 8, find your exponent button, to the power of 1 divided by 3. That gives you 8 to the 1/3. You get 2. Some people's exponent button is y to the x. Just make sure you use brackets around your fraction 1/3. Okay, so now we're ready to do this changeover. So we're going to change this limit that looks pretty stressful, and then hopefully the new one will look easier to solve. So we're going to change x approaches 0 to u approaches 2. X plus 8 to the 1/3 is u. We still have the minus 2. And then how do we do this x? Well, we have this box here that told us that u cubed was equal to x plus 8. So if we subtract 8 on both sides, we should get that x is u cubed minus 8. So this is called a simpler equivalent limit. Okay, so this whole limit now is changed from being in terms of x to being in terms of u, and it's an easier limit to solve. okay? And the bottom here is a difference of cubes, which we talked about in our last lesson, okay? And if you are forgetting, I'll just remind you, so we had a formula that a difference of cubed factors to give us a cubed minus b cubed is a minus b times a squared plus a times b plus b squared, okay? So we're going to factor then the denominator using that format. So that's u cubed minus 8. 8 can be thought of as 2 cubed. So u cubed minus 8 is going to factor to give us u minus 2. So our a is u and our b is 2 times u squared, that's our a, plus our u times 2, which is 2u, plus b squared, so 2 squared, which is 4. So now you can see that we have a u minus 2 in the numerator and the denominator that we can divide out, leaving us with a 1 on top. So now it's safe to let u approach 2 because we would not get 0 in the denominator, so we can go ahead and do that. So we're going to end up getting 1 over, and don't forget about the numerator, the 1 in the numerator, 4 plus 4 plus 4, which is 12. Oops, sorry, you didn't see that last part there. So we end up getting that this very complex looking limit is equal to 1/12. And we did that by using a change of variable to create a simpler equivalent limit. Okay, on to B, similar type of question. So this is our part that's complex. So we're going to let u equal x plus 27 to the 1/3. So then if we cube both sides to undo the 1/3, we would get that u cubed is equal to x plus 27. And then as x approaches 0, u is equal to this, so u is going to approach 0 plus 27 to the 1/3. So u is going to approach 27 to the 1/3, which is 3. So now we're going to change over our limit so that it's every x is in terms of u. So as x approaches 0, u approaches 3. X, okay, so that's kind of our trickiest part there maybe, after we've done the initial stuff. So we've got that u cubed equals x plus 27. So if we get x by itself, we'd subtract 27 on both sides. So we can replace this x here. So we need brackets because it's got two terms, a binomial u cubed minus 27. Over x plus 27 to the 1/3 we define to be u, we let u equal that, minus 3. So there's our new equivalent limit. That does look easier to solve. We've got a difference of cubes on top. And okay, so then factoring that difference of cubes, we would get u minus 3 times u squared plus 3u plus 9 over u minus 3. And then we can divide out the u minus 3's. So now we just have a 1 in our denominator, which is great. So now it's safe to let u approach 3. So we're going to get 2 times, so 3 squared 9, plus 3 times 3, 9 again, plus 9 again. So 2 times 27, which is 54. So we evaluated that limit by, again, using a change of variable. Okay, the next one. So limit as x approaches 1, so you can see we can't substitute 1 in, we get 0 in the denominator, of x to the 1/6 minus 1 over x minus 1. So here, this part here is the part that's making us uncomfortable. Okay, so we're going to do our change of variable again and let u equal x to the 1/6. And then if we put both sides to the power of 6, we get that u to the 6 would be x. And then if we want to change over as x approaches 1, u approaches, so here's our let u be, 1 to the power of 1/6. And the nice thing about 1 is it doesn't matter what power you put 1 to, you always get 1. So 1 to the 1/6 is still 1. And now we can start changing our limit over. So limit as x approaches 1 changes to limit as u approaches 1. That was easy. X to the 1/6 we defined to be u minus 1 still. And x, so this part is probably the, well, it's not too bad in here, but we figured out that x was u to the 6, so that's easy. We can replace x with u to the 6, but we still have this minus 1. Okay, so we haven't really had something with a 6 before. So there's a couple ways to do it. The way that I like to do this is to think of u to the 6 minus 1 as a difference of squares first of all. So u cubed minus 1 times u cubed plus 1. So and if you try that, if you FOILed it out, you'd get back to u to the 6 minus 1. So u cubed times u cubed is u to the 6, because you keep the base and add the exponents. Then you'd have a plus u cubed and a minus u cubed. That would add to 0. And then negative 1 times positive 1 would give you the negative 1. So it is a difference of squares. So this was, to get from here to here, we did difference of squares. But now if you look at the denominator, you see that this is a difference of cubes. And this is a sum of cubes. Which both can be factored, but do we need to factor both of them? Well, we can substitute 1 into u cubed plus 1 and get 2. But if we sub 1 into u cubed minus 1, we get 0. So it's this one that we're worried about. So it's this one that we want to factor, hoping that it will divide out with something in the numerator, so that we can eventually let u approach 1. So just because something can be factored doesn't mean you have to factor it if it's not going to further the process or help you evaluate the limit. So u cubed minus 1 is a difference of cubes. So it's going to factor to give you u minus 1 times u squared plus 1u, which is just u, plus 1 squared, which is just 1. But we still have the u cubed plus 1. So if I'm kind of color coding, this u cubed minus 1 I factored to give me these two quantities multiplied together, but then I'm still multiplying by the u cubed plus 1 there. And then fortunately, once I factored, I can now divide out those u minus 1s. So now my numerator is 1 and my denominator is u squared, plus u plus 1 times u cubed plus 1. And now it's safe to let u approach 1 because I'm not going to get 0 in my denominator. So I can go ahead and do that. And here I would have 1 plus 1 plus 1, which is 3. Here I have 1 plus 1, which is 2, which means my limit would turn out to be 1/6. Okay, so again, we used a change of variable to make something complicated into a less complicated limit, although it still, takes knowledge to solve it for sure. Okay, the next one. So this one can look very intimidating, but if you look through it, it's the root x that actually appears twice, that is causing us to think, okay, well, I can't factor that. What am I going to do? So that's the part that's bothering us. So we're going to let u equal the square root of x. Okay? And if we want to get x by itself, which we'll need to because of this part here and here, we could square both sides. So the root of x to the power of 2 is equal to u to the power of 2, whatever side you do to one, you do to the other. So x is u squared. Okay, and then as x approaches 9, from this statement here, u would approach the square root of 9, which is 3. So now we can change our limit over. So from the limit as x approaches 9, we're going to change it over to the limit as u approaches 3. X is u squared minus 4. The root of x is u plus 3. Well, it's like a trinomial, simple trinomial. Again, the root of x we define to be u minus 3. So now we've changed something complex into something that looks much easier to solve. I can't substitute 3 in, so I'm hoping that factoring is going to help me. And the numerator is a simple trinomial, and where I would need two numbers that multiply to positive 3 and add to negative 4. So they'd be negative 3 and negative 1. So I can factor the numerator to give me u minus 3, u minus 1 over u minus 3. And then my u minus 3's would divide out. Now it's safe to let u approach 3. So my answer is 2. Okay, here's a tricky one. So we've got a 6th root of x and a 3rd root of x. So when you have that, you want to take the smaller value, I guess, the 6th root of x rather than the 3rd root of x, and let your u equal that. So let u equal the 6th root of x. Oops, that didn't look very good. Which is the same as having it equal x to the 1/6. Okay? And then to figure out what u is then, I would put both sides to the 6, or sorry, what x is. So that gives me x to the 1 on this side is u to the 6th. Now, if we kind of look at this as a defining equation, we also want to know what x to the 1/3 is. So if I put this side to the 1/3, because 3rd root of x is x to the 1/3, that means I also have to put the left side to the exponent 1/3. So x to the 1/3, power of a power, u to the 6 to the 1/3, you keep the base and multiply the exponents. So 6 times 1/3 is 2. So the 3rd root of x is u squared. Remember that x to the 1/3 is the same as the 3rd root of x. So those are all equal. And then as x approaches 64, u is going to approach the 6th root of 64. Oops, not equal, approach. And you can put that into your calculator as 64 to the exponent 1/6, which is 2. So now we have enough information to change our limit over. So the limit as u approaches 2, so 6th root of x was what we let u be, minus 2, over 3rd root of x, we figured out was u squared, minus 4. So that really scary looking limit has turned into something pretty simple now that we've changed the variable, because the bottom is just a difference of squares. we can divide out the u minus 2's. Don't forget the 1 in the numerator. Now it's safe to let u approach 2. And we get that the limit is equal to 1/4. Okay. Now, our next question is evaluate each limit that's in indeterminate form. So it doesn't tell you that you have to use change of variable. It's we're kind of consolidating our skills and seeing if we know how we would go about doing one. So if you saw this one, think back, what do you think you would do? Hopefully you're thinking multiply by the conjugate, and that is what you would do. So plus root of 1 plus x here. So again, remember there's the FOIL to do in the top, but hopefully a lot of you are getting to the fact that you know that the middle terms are going to cancel out. So really what's going to happen is you're going to get 1 plus 4x. The two middles will cancel out, and then minus bracket, a couple people forget that, 1 plus x over x times the root of 1 plus 4x plus the root of 1 plus x. Close my bracket. Okay, so then that's going to be the limit as x approaches 0 of 1 plus 4x minus 1 minus x over x times the root of 1 plus 4x plus the root of 1 plus x, which is going to be the limit as x approaches 0 of, so 1 minus 1, 3x over x times the root of 1 plus 4x plus the root of 1 plus x. And now we can divide out the x's. So now it's safe to let x approach 0. We'll have 3 in the numerator over the root of 1, because 4 times 0 is 0, plus the root of 1 again. The root of 1 is 1, so that's going to equal 3 over 2. So that would be multiplying top and bottom by the conjugate. B, okay, so you could see, can I sub a quarter in? The square root of a quarter is a half. A half minus 2 times a quarter, that's also a half, so you would get 0. So this one, it would be changing the variable, change of variable. This root of x is what's making things uncomfortable. So we're going to let u equal the square root of x. And if we square both sides, we get that u squared is x. And as x approaches 1/4, u is going to approach the square root of 1/4, which is like the square root of 1 over the square root of 4, which is a half. So now we're ready to change our limit over. So it's going to be the limit as u approaches a half of 1 minus 4. Now what did x end up being? U squared. Root x was u minus 2. What did x end up being? U squared. So now the whole limit's been changed over from being in terms of x to being in terms of u. The top here looks like a difference of squares. And the bottom may confuse you for a minute, but there's a common factor of u. So let's do our factoring. So the difference of squares, it's going to be 1 plus 2u times 1 minus 2u. And in the denominator, we have a common factor of u. And then if you divide out the u, you're going to get 1 minus 2u. So you can see the 1 minus 2u's are going to divide out. So now it's going to be safe to let u approach a half, because then our denominator will just be a half, which is fine. So 1 plus 2 times a half over a half. So 2 times a half is 1, so 2 over a half. Same as 2 times 2 over 1, which is 4. So that turns out to be 4. C. So this one is one of those 3-layer fractions. We know from our work with finding the slope of the tangent that we have to get a common denominator in the numerator first. So our denominators are the root of 9 plus h and 3. So our common denominator in the numerator is going to be 3 root of 9 plus h. So here the numerator was 1. I had to multiply the bottom by 3, so I have to multiply the top by 3. And here my numerator was 1 again. I had to multiply the bottom by the root of 9 plus h, so I have to multiply the top by the root of 9 plus h. And that's still all over h. So now I can subtract the numerators over the common denominator, still over h. And so hopefully now when you would relook at it, if this had been your starting question, you would think about the conjugate of the numerator here. So I'm going to multiply by 3 plus the root of 9 plus h, and then also the denominator of the numerator, so that I'm really just multiplying by 1. So I'm doing the FOIL here. So in the numerator of the numerator, I'm going to end up with 9. That's my 3 times 3. Then my outer and my inner will add to 0. And then my 2 last will multiply to give me minus bracket 9 plus h. And that's over the denominator, which is going to be 3 times the root of 9 plus h times 3 plus the root of 9 plus h. And then I'm going to multiply this whole thing by 1 over h. So now I've got a 2-layer fraction. Okay, so now I want to simplify the numerator and the denominator. So in the numerator, I'm going to have 9 minus 9 minus h, be careful. And in the bottom, I've got a bunch of things multiplying together here. I've got 3, I've got the root of 9 plus h, I've got this binomial 3 plus root of 9 plus h, and then I've got h here. So I've really got 4 things all multiplying together. I can combine the 3 times h and get 3h here, put it out front, and that's my problematic h that I want to hopefully divide out. And then I've got the green one, root of 9 plus h, and then the pink one, 3 plus root of 9 plus h. So again, 1, 2, 3, 4 things multiplying together, 1, 2, 3, 4 things still multiplying together. So now the 9 minus 9 goes, and I'm left with negative h in the numerator, still this whole big denominator. And finally, these h's will divide out, leaving me with negative 1 in the numerator. So now that I don't have just a plain h in the bottom, it's safe to let h approach 0, which is going to give me negative 1 over, so as h approaches 0, I have 3 root of 9 times 3 plus the root of 9. So just try to simplify that denominator, negative 1, 3 times 3 times, that's going to be 3 plus 3, which is 6. So that limit turns out to be negative 1 over 54. Okay, that's a tricky one. You might want to star that one. Okay, so we had first we had to get a common denominator, then we had to multiply by the conjugate, invert and multiply, expand, divide out your h's, substitute. Last one. The limit as x approaches 1. We see if we put 1 even into the first part here, we'd get 0 of this. All right, so sometimes when you're given a limit and you're not sure what to do, you're just going to do what you can do. So there's not really anything I can do in the first bracket, but in the second bracket, I could subtract those fractions. And in order to subtract those fractions, I would need a common denominator. So I'm going to look at the two denominators here, and the common denominator is going to be x plus 3 times 3x plus 5. So within this bracket then, I'm going to have this common denominator. You can see why we did simplifying rational expressions in grade 11, so that you would be able to handle the algebra of subtracting these. So here I had to multiply the bottom by 3x plus 5, so I have to multiply the top, which is just a 1, by 3x plus 5. And this one I had to multiply the bottom by x plus 3, so I'm going to multiply the top, which is a 2, by x plus 3. So now I can subtract the numerators in the second bracket over the common denominator. And then I'm going to expand and simplify the numerator of the second fraction here. So that's going to give me 3x plus 5 minus 2x minus 6. And then my denominator is still going to be x plus 3 times 3x plus 5. So 3x minus 2x is x. Positive 5 minus 6 is negative 1, which works out nice for us. Now we're multiplying rational expressions, so we can multiply the tops together. So 1 times x minus 1 is just x minus 1. Bottoms together, we've got 3 binomials, x minus 1, x plus 3, and 3x plus 5. So that worked out really nicely because now we can divide out the x minus 1s, leaving us with a 1 in the numerator. So now that there's no x minus 1 in the denominator, it's safe to let x approach 1, which is going to give us 1 plus 3 is 4, times 3 times 1 plus 5 is 8, giving us 1 over 32. Our limit. All right. Thanks, guys.